think we are live on YouTube. Shall we start?
Okay, want to start now? I will do a quick intro first, then I'll hand over to Baruch.
Yep.
Okay. All right. I think let's start. People are streaming in. I think it's okay. Yeah. Thanks for making time. This is the second GoSG meetup online. Hope everyone is doing well. It's COVID-19. So just a quick introduction. This is the Go Singapore Meetup group, and we typically get 30 people for meetups. Yeah, so that's a typical size. Right. A quick shout out to our partners, and Michael is here from Engineers.SG, so logo. And Hackerspace was one of the places of physical location we had for our first online meetup. But now is a tighter measure, so we can't go there. Hopefully, we will be back soon. Right. We are also looking for more speakers, and this is the link, and I'll just let it stay for a bit. So if you are keen to speak at GoSG, and with this new online meetup format, I think it's much easier. If you have friends you want to speak, please refer them to this link. Right. Okay. Anyway, without further ado, let's introduce Baruch. Right. Maybe you want to give yourself a short introduction before you start. Yeah. Okay. Over to you.
Yeah, thank you for having me, and it's nice to be there. I would like to be in person. Obviously, I love Singapore, and I would rather prefer to do my talk at 7 in the evening than 4 in the morning. But it is what it is. Yeah, so my name is Baruch. I have an intro inside my slides, so we'll talk about me over there. I'm in California now and working for JFrog, so you will hear all about it in my talk. So if we are ready, let me just share my screen and we will be all good to go. Here we go. All right. So we are going to talk about modules. I frankly wanted to start with a little poll, and unfortunately we didn't have time to put the poll in a Zoom meeting, so we will do the poll in the chat. I think it will be fine. So let's start with me asking, when did you start working with Go? How much experience do you have? Was it 2012 or 13 or 15, 17, or maybe you are newcomers? Let me know in chat so I will know where to aim in our story. There we go. People start answering. Thank you. Yeah. Okay. So, there is. I'm glad to see that the diverse group. Some people new to Go. Some people are here from 2013. That's Javier. That's very impressive. All right. Cool. So we'll talk about everything, I guess. That'll be the right, the right approach. And as I mentioned, my name is Baruch, and I'm Chief Sticker Officer in charge for stickers at JFrog, but also head of developer advocacy. And for the stickers, it's a little bit of a problem because if I would there in person with you, you would get stickers. For now, you will just get the advocacy. The most important part on this slide is my Twitter handle at @jbaruch. Follow me on Twitter. We can have two-sided conversation, which is always nice. This is my disclaimer. It's an amazing, it's a diagram from an amazing book called The Culture Map. If you work with multiple cultures, as you probably do, especially in Singapore, but throughout the world, you definitely should read it and learn how to work best with different cultures. You can see that most emotionally expressive and confrontational people are from Israel and Russia. I'm from both. I was born in Russia and raised in Israel, so my style might look a little bit aggressive. I apologize for that. And this is the most important slide of today's talk. I prepared a special page for you. If you go, not now, but after the talk, to jeffrog.com/show notes, the slides are uploaded there. I will upload the video once we are done to their page as well. All the links for everything I mentioned, including, by the way, the culture map, the book that I just mentioned, are there as well. There is a place for comment, ratings, and a raffle. We raffle JFrog t-shirts for you. So and we do awesome t-shirts. That's one of them you see with Gopher and JFrog and Frog and what's not. We have really cool t-shirts. So go there, participate in the raffle. We will ship you t-shirts for the winners. Okay, so let's start with our content. And the first question is why we even have a problem that we need to solve with Google modules in 2018. And the reason why, to understand why we have a problem, we need to go back in time to 2007. It's late 2007. It's like 12 years ago. And here we need to understand that the key players in Google back then, like Rob Pike, obviously, as the person behind Go, realized that they in Google need a new language. And they had a problem. One of the biggest problems were build time and dependency management. You can see that 2003, they had Makefile that built the entire Google, the entire Google build. And obviously it was very big problem, and they tried to solve it. There are also others. They didn't like the major languages that were used in Google back then, which was C, C++, and Java, and they looked for a better solution. But also the dependencies, the dependency management, the modules were really, really big problem. And then they came up with a simple solution in Go, how the dependencies will work back in the beginning of Go. So the idea was that, first of all the dependencies are sources, and that solves a lot of problems that dependencies in C, C++ world have when the dependencies are precompiled binaries. And then obviously, depending on the platform that you are using, you need the right binary. And if you look at dependency managers for C, C++, like Conan, in order to have a dependency which everybody can use, you actually need to cross compile and build your module for 40 different platforms. If instead you give up on the idea of precompiled sources, dependencies, and just provide dependencies and sources, then everything is easier, because you will download the source and you will compile it with whatever you are building to the platform you are building. So dependencies are sources. All you do is you import as version control path, and then they will be downloaded. Everything will be dumped together into one source tree, what is called the GOPATH, and then you compile everything together, and then it's fine. Well, not really. I mean, it's definitely simple, but there are problems. And the problems are, for example, how do I know which dependencies do I use? If the dependency declaration is buried inside my import files, in order to know which dependencies I use, I need to go through all my source files and find those dependencies. If I work with your code, or if I look at, if I use your code as a dependency, how do I know which dependencies did you use in turn? Here, even looking at the import won't help, because I don't know how to distinguish your code against the code of your dependency. How do I know which dependencies exist, or which dependencies should I use? How I know if the code that I'm editing right now is mine, or I accidentally start editing the code of my dependencies? And generally, I have no idea what's going on. It's a really, really big problem. And if you look at statements of some important people in Go community, like Dave Cheney, for example, you can see that they suffered a lot back in the day without proper dependency management, right? So you can see they resorted to email semaphore. When someone fixes a bug, they send an email and saying to everybody, just run update. This is obviously was a disaster. But Go maintainers for a very long time kind of denied that the problem even exists. So you can see here advances from the Go core team, like from Brad Fitzpatrick, check your dependencies into your own version control. They suggest not relying on others people version control, but download the dependencies and check them in your source control. And then it's a like duplication of dependencies. And Andrew Gerard actually mentioned that it's not our problem. It's not the role of the tooling provided by language to dictate how you manage your code in production sense. So go ahead and build your own dependency management. And it's more of the same, more from Andrew. If you need to build any tooling around Go users like Git, Mercurial, and Bazaar, you already understand those tools, so it should be straightforward to integrate with whatever system you have. Again, go ahead and build your own dependency manager. And then Brad even saying, you know what, the Go get that you use for dependencies, don't use it for dependencies, because then it's a mess. Well, he's right, but they don't provide any alternative. And obviously, if they don't provide any alternative, then the next thing you know, there are 19 dependency management provided by community. So here are some of them. Again, this is quiz. We are not going to do it, unfortunately, online, but I will just tell you. So Go DAP.
Hello.
Bro, I think you are muted.
Hi, Baro. Yeah, I think you're muted. Yeah.
How about now?
Oh, good, okay.
Okay, yeah. So sorry, it's some kind of a USB issue. Then my audio is getting disconnected without me even noticing it. So please let me know the second you don't hear me anymore. Okay.
Okay.
Okay. So I should restart this slide, or did it disconnect earlier?
Yeah, I think you should restart this slide.
Okay, yeah. So I said that I would like to do a little quiz with you, but unfortunately it's impossible via Zoom. So I will just give you both the questions and the answers. And the first question is, what package manager GoDeps.json uses? And the package manager is called GoDep, because GoDeps is actually taken for a name of another dependency manager that uses dependencies TSV as packages. And there is also out of the list, Go Vendor, Go Vend, Go Ven, and GV, all of them are valid dependency managers. And then out of trash, garbage, and rubbish, even there is a real dependency management actually called trash. And then there is one that's called like a weapons manufacturer, Glock, for Go Lock, G-Lock. So anyway, it's a lot of fun. It's 19 different dependency managers, and everybody does what they can. So the interesting part about all of them, and I really mean all of them, that all of them use vendoring. And vendoring, I will explain what it is in a second. It's something that is promoted by the way Go code is structured. And you remember before Go modules, you were used to put all the Go code, your dependencies, into this special directory called the GOPATH, which included all your source code. And the idea of GOPATH comes from another concept very popular in Google called the monorepo. Monorepo is the idea that all the code for your entire organization is inside one source module, one source code, one source module. And this is what GOPATH actually is. You take all your projects and all the dependencies of all your projects. You just dump everything into one directory and check it inside inside your source control. And while there are a lot of advantages for monorepo, there are two very big problems with GOPATH as a manifestation of the monorepo for our Go. The first, it only allows only single version of any given package to exist. Right, so if you have two different modules that use the same dependency from different versions, you cannot have the same dependency in different versions, just because the directory, the sources are not named with version. And if you want to put a new version, you will override the previous one. And the second, and that's the most important one, is we cannot differentiate between the code that is our code and the code which are our dependencies. Not only we cannot do it programmatically, there is no way. Most of the time, after some time, we cannot even recognize our own code. And then even by looking at the code, we don't know if we are working on our code or the dependencies. So what is vendoring? Vendoring is exactly what Brad suggested, is when you take the source code of your dependencies and actually merge it with your code in GOPATH, and then you deploy it to your source control. So basically take the dependencies, merge them with your code, and deploy it to your version control. And this is why you cannot actually differentiate between your code and the code which you depend on. And vendoring, actually, it's the worst kind of forking. So you know that forking is bad. Versioning is actually worse, because copying all your files at some version from one version control repository and paste them into a version control repository, this is vendoring. It is a really bad idea. So first of all, you lose all the history, you lose the branches, you lose the tags, you lose everything, you start anew. Second, you detach your version of dependencies with the original version, with the original source code, so you cannot get any updates. Obviously, in some point of time, you will start, you will need fixing something in your dependencies. Instead of fixing in the original source code, you will start fixing your fork, and this, when you diverge and actually create a very big fork, which does not report back. It wastes space. That's the least of the problems, but still, if you have a lot of dependencies, you manage them twice. And obviously, the biggest problem is that you have no idea what version of the code you actually forked. So even if you want to take a newer version, you don't even know where to start looking, because you have some version of the code, you don't know which. So this is all very bad, and obviously people realized it a long time ago. So one of the tricks that people used are submodules, Git submodules. Well, Git submodules make it a little bit better, because then instead of making a fork, you merely refer to others people's code, but you still have no idea which version are you using. And when you use submodules, you need to manually connect every dependency as a submodule. And obviously, all the problem with Git submodules, which are a lot, stuff like branching and switching between branches and forks, is just a horrible pain in in Git submodules, and all that is not going anywhere. And obviously, if you have other teams that provide you with dependencies in-house, and since you are in a monorepo, then you need to connect a directory from the same repository as a submodule of the same repository. This is just a nightmare. So basically, this is where the Go community found itself in 2017. And the question was, okay, now what? Everything is in a pretty bad shape. How can we move forward? And the next thing that happened was an experiment. And this is obviously a very, very good thing that Google does. Instead of just rushing into one or other solution based on their assumptions, they experiment a lot. And one of the experimentations was the GoDep experiment, the official experiment of dependency management in Go. The person who was behind this experiment, his name is Sam Boyer, and he is all around amazing chap. One of the best reads in the internet is his blog called So You Want to Write a Package Manager. And you can see that while it looks like purely technical problem, which should be solved by purely technical solutions, and then you start developing a project manager and you discover that software is terrible, people are terrible, there are too many different scenarios, nothing will really work for sure. It's provable that nothing will really work for sure, and our lives are meaningless perturbations in swirling vortex of chaos and entropy. Well said, Sam, well said. We had an honor to host Sam Boyer in one of the latest episodes of the Dev Speakeasy podcast. That a podcast that we run in JFrog when we interview amazing people in DevOps. Sam Boyer is definitely one of them. The show notes, if you remember, if you go to jfrog.com/show notes, you will find there a link to an episode of the DevOps Speakeasy podcast with Sam Boyer. So do not miss. He's amazing. And we spoke about the Go Deb experiment in deep. So what was it? How it was structured and what it did? So first of all, we switch from the GOPATH, from the monorepo, and then, well, it's still obviously possible to have all those separate directories in the same repo, but you don't have to. So you have an option to switch from monorepo by walking away from GOPATH. You have a local cache for dependencies. Instead of dumping the sources into your source tree, you have a local cache. You have a proper version declaration. You have a proper conflict resolution. And conflict resolution is about what's happening if your dependencies are transitively dependent on different versions of a certain library, how the dependency management mechanism will make a decision which version is better. And mostly because of that, but also because of other reasons, we entered into a conflict over conflict resolution. So Sam Boyer and Russ Cox, who is the leader of Go project, didn't agree on some details of implementation about conflict resolution stuff like Boolean satisfiability problem. Is it even possible to solve the problem of conflicting dependencies? Satisfiability modular theories on how it should be solved, stuff like minimal version selection and semantic input versioning, and basically, there is a lot of things to argue about, and they indeed did. So again, if you go to show notes, you will see links there for both versions of the conflict, what Sam said about it, what Russ said about it, and all that. So with that, a decision was made to step away from the Deb project and create a new version and a new package manager. A new package manager was called vgo, version Go, and now this is what became an official Go modules. So what is it? So first of all, it's clear that Go ran 10 years without built-in dependency manager, and there are 19 dependency managers provided by the community. So the question, the backwards compatibility and migration was and still is a critical issue. How do we migrate from all those 19 dependency managers, and sometimes working without it, to actually Go modules? And it's super easy. All you do is you type go mod init, and then a mod file is created. Go mod file is the declaration of your dependencies. And then the rest is exactly the same. You use imports in your Go source files, and the code just works. So obviously there is some very serious magic going on. And let's talk a little bit about it and look under the hood of what's going on. So what actually happens is that Go modules convert almost every package manager to version declaration into Go mode. So you can see there is a list of converters, and they use all of those. The glogs, the Go deps, the Go pkg, the Go dep, and most of them are actually being converted from their custom declarations to an official Go mod declaration of versions. So Go mod is the file when you have the versions, and this is where the versions are converted from different community package managers. Now, what happens if you just go ahead and add an import in your source file and then run a build? So a couple of things happen. So first of all, Go will check if this import is a URL. Well, it's a URL, it has to be by standard, but then they check what's beside this URL. If it's just a version control, if it's an import of some GitHub URL, then the sources will be cloned from this GitHub URL, and then Go will build a module, which basically means create or just if Go module exists in this dependency, it means just archiving it. If it doesn't, it's create the Go mod file, the declaration of dependency, and then archive it, and then the module just can be served to you as a dependency. If it's not a version control, maybe it's a web page. If it's not a web page as well, then there is an invalid path message. If it is a web page, the next we will check for Go import meta tag. If Go import meta tag is found, then we follow the URL for this Go import, and again do the same check. If under Go import it's a version control, then everything is good, and if not, we will just do the same check. If it's not a Go import, then obviously we get the invalid import path. Another thing that is done after the module is served is that whatever found will be recorded in our Go mod file, and its checksum, its version and checksum will be recorded in go.sum. Sum.go file, which is the checksum file that has the checksum of our dependency. So the last question is the version control, the import path does not include the version, right? So we go, and when we use the import path, we don't mention the version. So how the version is selected? And the answer is very easy, but not always obvious. And the easy answer is latest compatible version tag. This is what the spec says. This is what needs to be chosen. And here we have a lot of questions. First of all, what compatible means? Latest compatible version tag means that your package manager somehow magically will select the right version that is compatible with your code. How it's even possible? It's possible only when we assume that semantic versioning works. What does it mean? It means that the latest version of 1.x.x is always compatible with 1.0 and 0. And that means that selecting a compatible, latest compatible tag means selecting the latest compatible tag inside my major version. So there is a premise here that import path string should always be backwards compatible. So if, for example, I now import my module without specifying the version because we don't, then Go will pick the latest tag that exists for the same major version. So let's say I have tags 1.00 and 1.10, then Go will select 1.1.0 because it should be fine. It should be backwards compatible with 1.00. Now, I mentioned within the major tag. Now, what about version 2? What about the next version tag? Well, this is an incompatible code by definition of semantic versioning, and that's okay, but it means that it cannot use the same import path. You need to add v2 to the module path, and then Go will know that it should check the latest compatible version under v2. It will look for now not 1 dot whatever latest, but 2 dot whatever latest. And then obviously you use v2 in the import path. So you do something like that. You do import GitHub my module v2, and then obviously Go will know to search for the latest version under 2 dot whatever in GitHub to provide it. And that's a very elegant decision that is based on the fact that actually everything below major version, all the minor versions and the patches are actually updates, and they should be backwards compatible. A major version is a completely new dependency, and this is how the problem of not mentioning versions at all actually served. So this is elegant and beautiful and actually works if we rely on the promise that semantic versioning works. Now, what happens if I want to use a package that doesn't have any tags with semantic versioning? Then Go will use something that's called pseudo versions. And pseudo versions is actually version.000 and the timestamp and then the hash of the commit. And obviously versions below version 1 are not supposed to be compatible with each other. So no highest version will be chosen, but you will also be dependent on the same version, on the same commit that this semantic versioning was created from. And that means that no conflict resolution is possible, because if you have two different versions of this dependency, Go won't be able to pick the highest version because they are not compatible with each other. And also it means that you will never get updates because you will always be stuck on this version. If you use such a dependency, it is advisable to approach the maintainer of the dependency and actually ask them to create a version in semantic versioning and start versioning their sources. Okay. Now, obviously, semantic versioning sometimes break because, as Sam mentioned, people are horrible, they make mistakes, and then there is a version which is supposed to be backwards compatible but is not. You can always ban such a version, but providing version something or later. So you do it with the syntax or more equals and then the version, and everything after this version will be selected. You can also exclude one version and say everything below this version and everything above this version is fine. Or you can actually replace a version and say, when someone asks this version, give them that instead, because we had a problem and then we issued a patch. So every time someone refers to the bad version, give them the patch instead, which is wonderful. And the last topics I want to discuss is, where do we find those modules? Obviously, we don't want to rebuild them from scratch anytime. And for that, we actually want to move from vendoring to a hierarchy of module repositories. So first of all, module should be immutable. A module at a version construct should always refer to the same thing. GitHub my user my repo version 1 should always be the same. But the tools that we use now to store our dependencies and sources, namely Git, cannot guarantee that, because we can always do force push into an existing tag and change it. And this is a horrible idea, but people do it. And then what we end up is inconsistent builds, not reproducible builds, because I build exactly the same thing with exactly the same dependency and I get different results. So in order to fix it, what Go now does is they create those modules as archives of sources, and then they checksum it. They checksum it, and then they provide this checksum that we will know that it refers to the same version all the time. And those checksums can be validated against the modules to check that version 1 is always version 1. Where do we keep those modules? So there is a hierarchy of caches that provide us with the modules. And the lowest level is the local cache. This is what GOPATH is now used. Instead of being your source of, your directory of sources, it's now a cache for your dependencies. So, and the benefits is obviously it's on your local machine, it's immediate access, but you cannot share it. And as a local cache, it can be deleted.
I think you are muted again, Bert.
All right, thank you for letting me know. So local cache is immediate access, not shared, and can be wiped. And this is what your GOPATH is now used instead of being the source, instead of being directory of your sources. Organizational cache is still fast because it's on your LAN, but it requires infra unless you are opting for the cloud option. And it's shared across developers, and this is important because this is allows you to publish your own modules for the usage of other teams. So whenever you have an organization, you definitely should have this as well. And obviously the example that I really suggest is JFrog Artifactory. We're going to talk about that in a second. And then there is the public proxy, the public cache, the public proxy, and this is where this is kind of the source of your pre-built, which basically means archive modules. So they are highly available. CDN doesn't require any infrastructure and free. And there are two most important ones. The first is proxy.golang.org, and that's the official module registry of Go provided by Google. And there is a JFrog Go Center, and I will touch on the differences between the two. Now, you remember how we said the public caches have this checkbox, the checksum verification. But if you have your own private modules, they don't have an entry in this checksum base. So what do? How can you instruct Go to bypass the verification? And the way you do it is you use a Go NoSumDB environment variables, and then you list all the packages that you don't want to check against the checksum. So you do something like that. Go NoSumDB, and then you specify your import prefix that should be excluded. So how do you use the Go proxy? This is how you do export Go proxy, and then you provide a list of all the sources from which the modules should be downloaded. And you go my SM proxy, that could be your in-house proxy, and then proxy.golang.org, and that will be the central, and then you always finish with direct. Direct means if you didn't find the module already existing in any of the proxies, any of the repositories, then go to the version control, download the sources, and build the sources locally, as we saw earlier. Another option, which is both more efficient and easier, is instead of providing the list of proxies to the GoProxy variable for each and every client machine, for each and every developer, for each and every build server, instead you can use JFrog Artifactory and then actually specify it and then direct. And I will touch on why it's possible in a second. So first, let's see how the list of proxies work. So again, you have access import path in in your source, and then Go will check if the variable Go proxy is set. If it is set, then it will take the first value inside this setting and will check if the model found. If the model found, then we can just serve the model. If it's not found, we will check the Go proxy variable for its next value. And we will check in the next value and all the way to the way that we see the direct variable, the direct entry. Direct entry means, okay, there are no modules found in any of the repositories. Now we need to go ahead and build it. And then we will do all the checks that we did previously. If it's a version control, then clone the sources and build the locally, and then share it. And if it's a web page, and it's not a web page, you know, all the metadata and everything, basically, right? So now instead of going to version control from the beginning, instead we will start checking for this Go proxy variable, and for each and every entry, check if the modules are there. And it takes time because it's network handshakes for each and every Go module. In order to simplify it and also speed up the build, you can use JFrog Artifactory. And JFrog Artifactory has 3 types of repositories for Google modules. It has the remote, which will proxy some other Go module registry, for example, Go Center or the pkg.golang.org. It has a local repository for your private modules. This is very important because this is how you share modules within the team which are not exist in the public repository. And then we have a virtual repository that exposes one Go proxy for any number of repositories. So you can proxy the official Go repository proxy, you can proxy Go Center, you can proxy your local repository, and all will be exposed in a single Go proxy entry. And this obviously makes it faster because there is only one round trip to the network, and also simplifies the setup for the developers and the CI environments. All you need now is one Go proxy instead of list of 4. And that's obviously better and simpler. So what this system provides us is immutable and repeatable builds. We have immutable dependencies. Once the dependency made itself to the public registry and have an entry in the CHECKSUM DB, then we are 100% sure that we will always get the same dependencies. We don't have lost dependencies anymore because it's impossible to remove a dependency from a module cache. It's possible to delete your GitHub repository and then everybody will have access, but the build module will stay in the Google package proxy or in Go Central. And obviously, once you have Artifactory as your organizational cache, you are even protected from downtime of central repositories and or GitHub. And also, as I mentioned, faster builds. They're faster because they are cached, the dependencies are cached, and also they do not need to be built from scratch as you would do without the proxy. Now, the last part is you have two different repositories. Which one, central repositories, proxylang or GoCenter, which one do you use? So you can see here a list, reliably serves Go modules, obviously both of them. This is their main purpose. Checksum DB support, yes, of course, this is very important. Search, there is no search on proxylang.org. There is a very nice full text search in GoCenter, which also ranges the dependencies, trying to guess which one do you want. How do you add modules to the index and to the registries? The proxylang.org uses their own algorithm on deciding which one needs to be used. For GoCenter, you can actually ask it to build a module for you and start serving it. Statistics only on GoCenter, metrics only on GoCenter. Default in Go toolchain, well, the official proxylang.org. Google controls the toolchain, Google controls the repository. This is what will be by default. The good news are you change it with one line of export. As you saw, you say go proxy to your Artifactory or to GoCenter, and then you start using GoCenter. And then vulnerabilities. Vulnerabilities scanning and information about Go vulnerabilities only exist in GoCenter. And if you wonder if the hashes are not helping, well, they are, but just a little bit. Hash protects against some types of supply chain attacks, and that basically means that no one can pretend they serve you dependency when they actually serve you something else. But that's all. They don't protect you from other types of supply chain attacks, and they definitely don't protect you from vulnerabilities inside dependencies as well. All checksum do is promise that what you asked is what you download, but it doesn't help you knowing that what you ask is actually problematic. And just couple of the comparisons between them in the more like UI. This is proxy.golang.org. You can see there is basically no UI. There is explanation on what it is, and there is no list, there is no search, there is nothing. And this is GoCenter. You can go and search, you will get information, readme, the mod file, and then you will see the security. And here is an example of vulnerability. And you can see here what the severity of vulnerability and all the description and the CVE that you can go and check on more information. All this powered by JFrog X-Ray, which is the security tool in the JFrog portfolio. And this is how the metrics look like. So you can see here open issues, forks, contributors, watchers, pull requests, and downloads. So you can see here a lot of valuable information that will help you choose the right dependency, something that obviously a very minimalistic UI of proxy.golang.org won't help you with. So GoCenter is where you go when you actually want to choose a library, and then doesn't matter what you consume. So with that will be all for me. Again, jeffrog.com show notes. I'm also pasting the show note link in the chat, so you will be able to go there directly. And my name is Jay, on Twitter is @jbaruch, so follow me there. And gocenter.io, that's the link for GoCenter. With that, that's all for me. Thank you very much. Questions?
Thank you, Baruch. And any?
I think I sent, sorry, I didn't send the link. Now I did. Here you go.
Yeah, okay. Any questions from anyone? You can either use voice or you can type. Yeah.
Yeah, I think voice is easier. Since we're all on a Zoom meeting, just unmute yourself and let's do it as much close to a real meetup as possible.
All right, going once, going twice. I think okay.
Okay.
All right, thank you, Baruch.
My pleasure. Thank you again for having me. Just a reminder that there is a raffle on the show notes that you really want to participate. It's very cool Jeffrey t-shirts. And with that, thank you again for being here. Thank you for having me, and have a great night.
Thank you for staying up for us. Thank you.
My pleasure.
Okay, and without further ado, may we invite the second speaker, Kenneth.
Yes, okay. Let me share my okay, wait,
Okay, thank
share
you.
screen.
Do you want to turn on your video as well?
Oh, sure. Wait me. Start here. Okay, guys. So, good afternoon, everyone. Yeah, thank you from the Golang Singapore to inviting me for speech, for having me share about one topic, quite interesting topic to your. Okay, tonight I will share about optical character recognition implementations with Golang. So without further delay, let's start. Let me introduce myself first. Sorry. Okay, my name is Kenal Ruchwadi. You can call me Ken. And I'm currently working in Shopee Indonesia as senior software engineer. In Shopee Indonesia, we're working about how applications and service to engage customers to use our product. Previously, I'm working also in Tokopedia and OVO. Tokopedia is one of the largest e-commerce in Indonesia, and also working with Golang at the time. And the second one is OVO. If you know Grab, Indonesia has also Grab in Grab. And the payment gateway that we use in Indonesian Grab is OVO. Okay. What's OCR? Why we should bring this topic tonight? Okay, OCR itself, it's an ability, a system that can scan an image of text and identify them into text document. I mean, like when the image and full of text, it will be scanned through and it will be converted into text document. So you can convert it into editable text that can be processed into your systems or third-party systems. And for the OCR itself, it has two sides. The first side is the training one. The training one, it captures various input from users because as we know, every human, when we write an alphabet, it's not exactly same. So that's why in OCR, we need various samples of one alphabet, and then system itself, it will capture, it captures and extract the data and identify whether they has age or they has unique curves, and they identify like, oh, that character may be classified as A or B or number or special character. And also in OCR, it doesn't only detect for the character. It also check about the grammar and the vocabulary. It is to increase the accuracy. And after training sections, and we establish some database about the grammar database and the character database, we have the recognition sites. In the recognition sites, user will input some inputs in the form of the image full of text. And then in OCR system, it will process it based on the training data from the character model database and maybe from the grammar database, and soon do recognition search. After the system is quite confident about the results, it will extract them in the word of sequence. As we can see here, it's the final results for that. Okay, we are already talking about what is OCR and how it works. But why we should know the OCR itself? Actually, in OCR, it's already implemented in various daily life use cases. First thing that I know is some of the fintech applications let you to scan your debit or credit card number, and then it will automatically input to your systems. User doesn't need to type it one by one, so system will let you input by itself. And in some country, there's some like camera to detect the speeding. When car is getting speeding, the camera also detect automatically the plate number of that vehicle. That's the OCR. And maybe in the airport, when you scan your passport into some portal or some gates, it automatically extract your name, your passport number, and so on. Moving on, so we're talking about the OCR, why we should study OCR, and then how we will implement it into our system. When we should start, what the system we should install. So the engine itself is called Tesseract. Maybe some of you know Tesseract, like, oh, that's the stone that Loki holds in the Avengers Infinity Wars. But no, that's not the Tesseract I mean, but this is Tesseract. The Tesseract OCR, the open source engine for OCR, and because it's open source, so it's free. And it also licensed with Apache and backed by Google. As far as I know, this engine is the most accurate open source OCR engine to date. And yeah, as I mentioned before, what is Tesseract OCR? Tesseract OCR itself is the open source C or C++ OCR applications. Yeah, after you download it and you install in your computer, you can use it directly. And the most accurate open source OCR engine to date. And if you install it with some certain instructions like apt-get installs or macports or brew, you will get the latest stable version. It is the 4.11 versions, which was released on 26 December 2019. And also the version 5.0, it's on progress. So if you want to use the 5.0 versions, there is an installation guide and you can apply it into your computer, but use it at your own risk because it's still the alpha testing phase. And as I mentioned before, it's under license with Apache 2.0 and back with Google. How to install? You can directly install the Git Tesseract with that link, github.com, Tesseract OCR, Tesseract Wiki. And as I mentioned before, if you want to install the latest stable one, you can go with apt-get install if you use Ubuntu, or if you use Mac, you can go with macports or brew. It depends on your application. Okay, so let me give you some demo related to the Tesseract. Okay, wait. Sorry. Okay. Okay, can you see my screen right now?
We still see your slides. Yeah.
Oh, just see my slides. Yeah. Okay. So sorry. Wait, I should give the demo first. New share. Okay, can you see my outside of my slide? This one, okay? Okay, so let me see. Okay. Now I have. Wait, I delete this one first. Remove it. Delete. Move class. Okay. Okay, I have two images here. I want to extract them with OCR, Tesseract OCR engine. The first one is here. This one. The advertisement one, that's full of text. And the second one, it's mixed up with Japanese text and the English one. So let me try first. The first one is called OCR test JPG, the file name. So let me type it first. Okay, clear. Can you see my font? Type in here.
Yes.
Oh, okay. So let me type it first. The Tesseract version to verify that it's already installed. Yes, it's already installed. And then Tesseract, the file name is OCR test JPG, and we want to output it into certain file. So we have to put the name of the file output. This output number 1, and we add options -L to define its language. Because it's contain 100% of English, so I put ENG in here. I put ENG in here, enter. Then it will be converted into new file. Output 1.
Hello.
I think we have internet problem.
Yeah, I think so. Apologies.
Let me try to coin that.
Technical glitch. Hold your horses.
This is where video meetup, online meetup for short.
Yeah lah.
Kenneth will be back in a few minutes.
Okay, sorry, my internet it's down, so I'm using my backup. So for my apologize. So what is my last presentations?
You were on the terminal. Yeah.
Oh, okay. Okay, let me continue from my terminal. My terminal, preview, no, not this one. Share screen, stop. Sorry, let me share, new share here. Share. Okay, let me continue. Sorry, my apologies for the technical issues. Okay, so as we can see, the output itself, it's 90% similar with the input. And we can see here, the publications of the work of John Knox, it is supposed will extend to 5 volumes. It's clearly same, but there's some errors happen, like this one, it's convert as does, and John Knox, it's convert to John Knox. Yeah, because the character itself, it's not the small character. Yeah, it's like not successfully, not successfully, more like there's some errors, and we should tweak it at the later when we want to implement this OCR. And also when we want to convert, there's one more, sorry, Japanese text PNG 10, we want to extract them. Let me clear it first. Minimize it. Let me clear it first, and then we do the same thing like shifting, tesseract, Japanese text, output number 2, and the language, because the language is mixed, there are two languages. It's the Japanese and the English one, so we use English plus Japanese. There you go. We have output 2 text. We just get it, and there you go. The output is quite similar with the input. Okay, moving on with the presentations. Okay, for the presentations. Okay, so we already know that the OCR works by command line, and we just give the inputs and we can put an output into text files. And the next question is, because our topic is about implementation in the Golang, how we integrate it into Golang? First thing first, we already have one library that integrate with the Tesseract OCR. It's called Goseract. Yeah, thanks to this developer, the developer photos, he made this library, and this library is also listed in awesome-go.com. So it's quite dependable library because it's already listed in awesome-go. And this library, it's also act as the bridge of the official C++ library of Tesseract and Golang. So this library purpose is to bridging the C and C++ library into Golang. As you know that Golang itself can compile C library. And now the question is how we will use this library. Let me give the sample code first. Okay. Can you see my Visual Studio Code?
Can.
Yes.
Okay. So let's start. As usual, we use package main at start, and we use function main at the first time. Okay, so we want to implement Goseract in this code. How we will do that? We should import first. We make the client library first. Client equals to Goseract library. Goseract.new client. Yeah, it automatically import github.com OTF10 Goseract. We already made the client. The first step we should do is define the image input first. So we type image input client.setImage. And my left hand side, there is OCR test.jpg. We use this one. OCR test.jpg. And not only that, as we do it in command line, we also define which language we want to use. So define the language. Client.setLanguage. We should use same as the command line. So because the input itself is mostly using English, we put in ENG here. Okay, we already config the parameter and how we will export the result. We put it like here, output, comma, error equals to client.text. Yes, that's it. Output. And as usual, we use error not equal to null. Let's assume we panic it if there's error happens. Panic fail to extract text. And of course, after successful, we should print out the output. Let me fmt print learn output. Here you go. Save it. Okay, let's try it. Go run main.go. Okay, we already get the export. Yeah, this is the result. It's similar with when we did it with the command line. Same. So how we integrate with that library, this library, and also we should install the Tesseract, OCR, and then we successfully implement it into Golang. Okay, back to the slide. Actually, what I show you, it's the naive approach. We just completely use that image directly and extract the text. But the current issue is, there is some technical limitations happen when we just use this naive approach. The first one is about the manual image pre-processing. As we can see this image, this is the full color image, and the color itself is not quite distinctive enough with other parts. So in order to make it more distinctive and more easier to system read it, we should convert this image into like this. Black and white, and looks like, yeah, that part it's quite distinctive enough. And next, it's about the image sections divisions. As you can see in here, the rectangle, each of the rectangle, it's have to be treated separately. I mean, like when we see that there's some rectangle has text and the background, the color is bland enough, and we cannot see the text itself. And some of them is quite distinctive enough. So you can use that area and extract them directly, and OCR will directly give the output as you expect. But some of them is, if that rectangle is not quite distinctive, like the most left, bottom left, bottom right, it will not extract as we expect. Maybe there's no output from that part. And the last one is about the blacklisting and the whitelisting the character. Yeah, the one case that when we want to extract the O characters, the 0 and the O character maybe almost cannot be different. So when we want to extract the number from the input that we expect all of the input, all of the character it's in number, we have to do whitelisting. We only include numbers in that part. So when we want to scan that card number, it will guarantee extract only numbers, because we only whitelist 0 to 9. And it also goes when we have input that only consists hexadecimal number. Hexadecimal number only consists 0 to 9, A to F. So we have to whitelist 0 to 9, A to F. Or maybe we want to avoid special character, we can use blacklist. Like we want to avoid ampersands, or want to avoid question mark that usually happens in that input, we blacklist that kind of character when we want to extract them to OCR. Okay, right. Actually, I want to tell you some story that before I implement the OCR. 1 year ago, there is one games that I quite love, and I want to implement the OCR because I want to do some streamlined process when we want to extract the numbers and we want to extract the data from the pictures. Yeah, maybe some of you knows the game called Gitadora. Gitadora, it's a game that made by Konami, and it's also appeared in the arcade. And 1 year ago, I have a task to extract the data from the image itself, because there is in this game, there's one application that can extract players' score and players' achievement into the image template. So I take that initiative and made a program to extract some important data like this one. I give a red rectangle in this slide, and I took the timestamp, song titles, scores, and achievement rate. I made these systems because at that time there is some initiative from the community to make competitions about this game, and we want to make it easier to all the submissions. So we create these systems, and we hope that we can reduce the manual interventions from users. So if you want to take a look for the repository, there is https://github.com/Kitadora score parser if you want to check it out. Okay, that's it. Okay, any questions so far?
Thank you, Kenneth. Any questions from the floor? Okay. Seems like no.
Okay. So yeah, let me close then. So if you have more questions, or maybe you want to spare some questions in the futures, you can send me email by kennardrichardi@shopee.com, or maybe kennardrichardi@gmail.com, whatever you suit. And you can also directly PM me by Facebook and Instagram. So thank you very much for all, and see you next time.
Thank you, Kenneth. Thank you. Thanks for presenting. Okay. All right. I think that's all we have for this round. Thank you for staying throughout. We have about 17, 16 people left. Thanks for those who stay behind. Thank you to the two speakers. Hope to have you back again. Okay, that's all, guys. Thank you for coming. See you guys again very soon. Bye-bye. Okay, bye.